In this demonstration, we're going to look at electrostatics, charging, and an electroscope by conduction and by induction. This is the electroscope, and in this electroscope we have a little pipe here that will move out when there's a charge on it. Charges collect on here, they redistribute themselves out, and the same sort of charge here and here, and those charges then repel this, causing it to move out that way. Let's see now if we can charge it using first the rubber rod and wool, which will produce a negative charge on the rubber rod. These demonstrations are very dependent on humidity. Okay, we're getting a charge transferred from the rod to the electroscope, but not much. Okay, let me try something else that produces a charge like that. I'll use my comb and what hair I have left, and produces a pretty good charge on here on the comb. We'll transfer the charge from the comb to the electroscope. Now, this was a negative charge, so there are electrons, and electrons have taken up residence on this electroscope, moving down here, some here and some here, and that causes the electroscope then to be charged. And if I bring a negative charge up to it, it causes it to move, to deflect more. What if I try a positive charge? Positive charge can be generated under dry conditions with a piece of silk and a glass rod. Notice it's causing it to collapse instead of, and that means that this side of the sign of this charge is opposite to that. Since that's a negative charge, this is a positive charge. Okay, in this case we have charged by conduction, and charging by conduction we get the same sort of charge. I had a negative charge here, so then a negative charge there. And we're going to look at the charge on this. You can see that the charge on this is negative. It has been produced by a negatively charged object. And when we charge by conduction, we always get the same sign of charge on the object that is charged as was on the charging object. Now we're going to do this a little differently. In this case, this charging is going to be done by conduction. I'm going to bring a charged object near to the electroscope, causing it to, if I can get a charge on this, but I'm not going to touch it with the charged object. Instead, I'm going to touch it with my finger, and then I'm going to move my finger, and then I'm going to move the object. It's slightly charged now. What if I bring this up to it? It causes it to collapse. What if I bring a positive charge up to it? It causes it to move further away. So what I have done is I produced on here a charge on the electroscope that is opposite to the charge on the charging object. That is done by the process called induction. What happened was, as I brought the charged object up to here and then touched it with my finger, I provided a path to ground for the electrons to leave the electroscope to my finger, and then when I moved my finger, the electrons could not get back. That left this then with a positive charge.